I welcome you all to the journey of our project titled PCB Plotter. Let me introduce to you my teammates Nishant Halgatti, Prajwal Navalki, Spurti Patel, and I am Sumit Athani. The project was successful under the guidance of Prashant Narayankar sir. We are thankful for his presence. Now moving to the problem definition. It says, design a semi-automatic drawing board which is portable, should be able to draw circuit schematics on copper plates or silicon plates. The cost of the machine should be within Rs 4,000. The maximum drawable area shouldn't exceed A4 size. Should be able to draw 1 to 2 drawings in every 25 minutes. Should run for around 3 hours. The machine should be able to draw circuit schematics on plates. It should have an indicator for the completion of the drawing to indicate on or off status. It should also contain a pen holder to hold the pen. It should draw along both X and the Y axis. Now function tree and functional clustering. Our PCB drawing board consists of 4 subsystem units. The first one is holding unit, second one is motion control unit, third one is processing unit, the fourth one is indication unit. The holding unit consists of PCB holding and pen holding. The motion control unit consists of X-axis motion, Y-axis motion, PCB movement, lifting and lowering of pen. The processing unit consists of taking input circuit diagram, printing output on the PCB. Indication unit consists of on or off indicator, processing indicator, and the completion indicator. As we have seen in the last slide, the subsystems are listed below. Now the generated concepts. Design 1. Robotic arm plotter. It consists of a robotic arm and 2 stepper motors for controlling. Design 2. It can draw vertically and it uses the tension to draw. Design 3, also called the XY axis plotter. It uses 3D printed parts as seen here, and next it uses stepper motors for higher precision. The design 4, also called gear mechanized plotter. It uses gears and the mechanism used is rock and pinion. Next, the selected concept. Keeping in mind the objectives, we assign the weights for the objectives, and then using pug chart, we could justify and accept design 3 as a project model.
I am Spurti. I am going to brief about virtual implementation using 3D modeling. This is the 3D model of our project. It indicates the motion control unit and the holding unit. The holding unit consists of X-axis clamp 1, X-axis clamp 2, Y-axis clamp 1, Y-axis clamp 2, Z-axis clamp 1 and Z-axis clamp 2. The Z-axis clamp 2 helps in holding the pen or any other material which is used to draw. We also have steel rods running along the X direction and along the Y direction. We have used GT2 timer belts along X direction and along the Y direction. The motion control unit consists of SG490 servo motor fixed on the Z-axis clamp 1, 228 BYJ48 stepper motor, one present along the X-axis clamp 1 and the other present along the Y-axis clamp 1. They help in motion of the belt in X and Y direction respectively. We have a platform which provides platform for the PCB board. It is connected in such a way that it runs through the steel rods and its motion is synchronized with the belt along the Y direction. The motion of Z-axis clamp 1 is such that its direction is synchronized with the belt along the X-axis. The servo motor helps in lifting the pen or pencil up and down while drawing takes place. We have used 4 idler pulleys, 2 along the X direction and 2 along the Y direction. These idler pulleys help in providing the tension required for the belt.
Hello, I am Prajwal. We will see the working of the circuit diagram. The Arduino gets power from the laptop. GRBL CNC shield is placed on the Arduino Uno and two drivers are placed on the CNC shield. These two drivers control the stepper motors, that is X-axis stepper motor and Y-axis stepper motor, and CNC shield controls the servo motor, that is Z-axis. Next, we will see the working of the flowchart. So, we will power on the switch. Then Arduino Uno and GRBL CNC shield starts. After that 28 BYJ stepper motor starts working, that is X-axis and Y-axis. Then servo motor starts working, that is Z-axis. Then GT2 belt pulley rotates. Then finally 2D sketch is drawn on the surface. Now we will move to the bill of materials. One servo motor, two stepper motor, one GRBL CNC shield, one structure base, one microcontroller, one GT2 timing belt having 2 meter, two GT2 timing pulley, then two idle pulley, two stepper driver, then a power adapter, and lastly 3D printed parts. Now we will see what are these 3D printed parts. 3D printed parts consist of two X-axis clamp, two Y-axis clamp, one Y-axis platform and two Z-axis clamp. We thank Makerspace for providing a good 3D printed parts for our model. Now we will see motor sizing and battery sizing of the entire system. The total weight acting on a stepper motor is 200 grams, so the torque is 0.26 kg centimeter. Torque provided by the stepper motor is 0.36 kg centimeter, hence it can be used. Now we will see battery sizing. Maximum current drawn by the stepper motor is 0.3 amperes, hence maximum current drawn by 4 stepper motor is 1.2 amperes. Hence total current drawn is 1.2 plus 0.3, that is 1.5 amperes. Total backup required is for 3 hours. Hence battery size is required is 4.5 ampere hour. Now we will see functional specification of the entire system. Holding the pen. It should hold pen or a marker having a diameter 1 cm. Holding silicon plate, maximum size is A4 size. And moving along X-axis and Y-axis, the power transmission used is belt drive. It should be able to lift and lower the pen. To lift and lower the pen, we will be using servo motor. It should take input circuit diagram. To take input, we are using Inkscape software which converts given circuit diagram to G-code format. It should provide the output on the copper plate. The output is drawn on the copper plate using a marker of a diameter 1 cm. It should indicate processes on screen. The percentage of completion, the task completed and remaining is shown on the GRBL controller software. At last, it should indicate machine on-off status. We will be using LEDs to indicate the status.
Hello everyone, I am Nishant Halgati and I will be explaining the simulation and modeling of a PCB plotter. So let us begin. Now, in the physical implementation we have used an Arduino Uno, the GRBL CNC shield for the controlling of the two stepper motors and the servo motors. The two stepper motors that we have used are the 28 BYJ48 stepper motors. These stepper motors are used for the motion of the X and Y axis, and the SG490 servo motor is used for the motion of the pen. So now let us have a look at the working. First the image is taken in the Inkscape software and then we use this software to convert it into G-code. Then this G-code formatted image is then sent using the GRBL controller software to the Arduino Uno board. The Arduino Uno board processes the input and sends this to the GRBL CNC shield. The GRBL CNC shield then processes all the G-code commands that are sent and then correspondingly makes this decision to either rotate the motor, stepper motor clockwise or anti-clockwise, or whether the servo motor has to be rotated by 90 degrees or has to be set to its default position. Now let us have a look at the simulation. Now, as we do not have the 28 BYJ48 stepper motor and the GRBL CNC shield, we have used a group of 4 LEDs to simulate each stepper motor. Now, in the first group of 4 LEDs, These 4 LEDs simulate the coils of the 28 VYJ48 stepper motor. Now here we can see that the coils are powered on in a clockwise manner. Hence the stepper motor rotates in the clockwise orientation. While in the other half we can see that the LEDs, the coils are powered on in an anti-clockwise manner. This leads to the anti-clockwise rotation of the other stepper motor. The clockwise or the anti-clockwise rotation is decided by the GRBL CNC shield which sends the output. Now the SG490 servo motor is either rotated to 90 degrees to lift the pen or to 0 degrees to lower the pen. This also is processed by the GRBL CNC shield. Now let us also have a look at the video which we had made prior to the lockdown of the physical implementation.